Here are the answers to the Unit 2 Getting Ready. Number 1, simplify these square roots. First we have the square root of 64. 64 is a perfect square, and so that answer is 8 because 8 squared is 64. Now the square root of 98. 98 is not a perfect square, but it can be factored. So we're going to rewrite the square root of 98 as the square root of 49 times 2. The square root of 49 is 7, and then I'll leave the 2 inside of the square root. So 7 square root of 2 is equivalent to the square root of 98. Number 2, question A. Here we have an equation, x squared minus 8x plus 15 is equal to 0. We're asked to solve this for x. Now there are different ways to solve quadratic equations. One way is to factor. So if this polynomial factors, then we can solve it for x. So this is a trinomial. X times x creates x squared. And I'm looking for two numbers that multiply together to make positive 15. And the sum of those numbers is negative 8. How about a negative 5 times a negative 3? That makes positive 15. And the outer product is negative 3x. The inner product is negative 5x. And combining that is the negative 8x. It's kind of like doing FOIL right there. Okay, because these are multiplied together and equal to 0, that means that either of these can be equal to 0. So x minus 5 could be equal to 0, or x minus 3 could be equal to 0. Our answers are x equals 5 or x equals 3. Now question B. Here we have x squared equals 27. So another way to solve a quadratic equation, this time I'm not going to factor. Instead, I'm going to do the square root of both sides. So I'll take the square root of the left side, and I'll take the positive and negative square root of the right side. Recall that there are two square roots of any number, positive square root and the negative square root. So our answers are x equals plus or minus the square root of 27. Now the square root of 27 can be simplified, a lot like in the first question we had done the square root of the 98. If we factor 27 as 9 times 3, 9 is a perfect square. And so this is plus or minus 3 square root of 3. Number 3, if f of x is equal to 2x minus 5, find these function values. First we have f of 4. So to find f of 4, we replace the letter x with 4. 2 times 4 is 8. 8 subtract 5 is 3. The value of function f when x is 4 is equal to 3. Question B, let's find f of negative 3. So we're going to put negative 3 in place of the letter x in the function. Right there. So 2 times negative 3 is negative 6. Negative 6 subtract 5 is negative 11. The value of function f when x is negative 3 is negative 11. Number 4, write the equation of the line shown below. I notice that this line is touching the y-axis at negative 3, and so the y-intercept of the line is negative 3. And then from this dot we can count rise and run to another dot on the dark line that will get us our slope. So it looks like if we rise 3 and run 4, we're right back on the line. And so our slope is to rise 3 and run 4, or 3/4. And so one way to write the equation is slope-intercept form, where you fill in the slope and fill in the y-intercept. There's an equation of the line. Number 5, find the slope of the line that passes through these two ordered pairs. This is x1, y1, and this is x2, y2, and we can find the answer with the slope formula. M equals y2 minus y1 divided by x2 minus x1. So we have 7 subtract 5 divided by 1 subtract negative 2. This is 2 over 3. There's our slope. Okay, number 6. write the equation of a line that contains these 2 points. Again, this is x1, y1, and this is x2, y2. So let's start by finding the slope. We have -6 subtract 8 divided by -4 subtract the 3. This is -14 over -7, which reduces to 2. We have a value of m. We can now use the point slope formula, which is y minus y1 equals m times x minus x1. Do you remember this from the first unit this year? So y subtract y1. y1 is the 8. x1 is the 3. M is 2, and then x minus 3. It says write an equation. Here is our equation. This is called point slope form. Okay, number 7, find the midpoint and length of a line segment that has these endpoints. Let's find the midpoint first. We might call it M. To find the midpoint, you average the x-coordinates, so 3 plus 9 divided by 2, comma, and average the y-coordinates, 5 plus -3 divided by 2. And this will make this ordered pair. 3 plus 9 is 12, divided by 2 is 6. 5 plus -3 is 2, and 2 divided by 2 is 1. 6 comma 1 is in the middle between that and that. Okay, we want to get the length. We can use the distance formula. So the distance formula is d equals big ol' square root, and inside here we have x2 minus x1 squared plus y2 minus y1 squared. Remember how this was connected to the Pythagorean theorem, and that subtracting the x values finds the horizontal distance, subtracting the y values finds the vertical distance. So we have the square root, and this is the x1, y1. This is the x2, y2. So we have 9 subtract 3 squared plus, and then over here we have -3 subtract the 5 squared. Let's do a little bit of work inside here. 9 subtract 3 is 6, and 6 squared is 36. Over here, -3 subtract 5 is -8, and -8 squared is 64. Adding those together, that's the square root of 100, which is equal to 10. So our length is 10. Now number 8, question A. Find the solution of this system of equations. And then in question B, explain the method we use to find the solution. Let's do it right here, number 8. Okay, we have a system of equations. There are different ways to solve systems. We could graph the 2 lines and see where they intersect. We can use what's called substitution method, or we can use what's called combination method. I'm going to choose combination method. My first step will be to copy down the system. Then I'm going to create an equivalent equation to the first equation by multiplying both sides of the equation by -5. I'm going to times it by -5. That's my transformation. That will create -5x minus 15y equals -20. I'm not going to transform the second equation at all. I'm going to leave it just as it is. Now I'm going to do the combination step of this method. This is called linear combination method. I'm going to combine these equations together, actually add them together in columns. When I do that, because the x terms are opposites, that will make 0x. There's no x term anymore. This adds up to -17y, and these add up to -17. Divide both sides by -17, and we have an answer for y. We're halfway done. Y is 1. We now want to find the answer for x. So I'm going to go back to the original problem. I'm going to choose either one of the equations. I'm going to pick the first equation. And because I know a number for y, I'm going to put that number in for y. So that will be x plus 3 times, fill in the 1, right there for y, is equal to 4. This is x plus 3 is equal to 4. Therefore, x is equal to 1. I can write my answer as an ordered pair. X is 1, comma, and Y, coincidentally, is also 1. So my answer to the system is 1, comma, 1. What that means is if I use 1 for X and 1 for Y, that will solve the first equation, that checks. And if I use 1 for X and 1 for Y, 5 times 1 is 5, 2 times 1 is 2, 5 subtract 2 is 3, it checks in that one as well. So this answer checks in both equations. Explain the method that we used. We used combination method. We could have used graphing method, which you learned in Algebra 1 class, and we could have used substitution method. It's another way that you learned in Algebra 1 class.